Hello everyone. Today, my group and I will be presenting on probiotics in camel milk. Camel milk has a rich natural microbiome, which means it contains a community of microorganisms that provide several important benefits. These microbes help protect the milk from harmful bacteria, extend its shelf life, and support gut health when consumed. They also play a major role in enhancing fermented camel milk products such as Shubit and Garis. The most common beneficial microbes include lactic acid bacteria such as Lactobacillus, Leuconostoc, and Streptococcus, Bifidobacterium, which supports a healthy gut microbiome, and some bacillus species that assist in nutrient breakdown. Multiple studies show that camel milk contains a wide range of beneficial bacteria, especially lactic acid bacteria. Some of the most important species include Lactoplantobacillus plantarum, Lactobacillus gasseri, Enterococcus faecium, Enterococcus faecalis, Leuconostoc mesenteroides, and Pediococcus pentosaceus. A large metagenomic study even identified more than 1,196 bacterial genera in camel milk, indicating extremely high microbial diversity. These beneficial bacteria have several important biological properties. 1. Acid and bile tolerance. They can survive the acidic environment of the stomach and reach the intestines. 2. Antimicrobial activity. They produce organic acids and bacteriocins that inhibit harmful pathogens. 3. Antioxidant properties. Many strains reduce oxidative stress by neutralizing free radicals. 4. Production of bioactive compounds. Some produce GABA, which may reduce stress and support healthy blood pressure. 5. Fermentation ability. They are valuable starter cultures for producing fermented dairy products. 6. Improved nutritional value. Fermentation increases amino acids and nutrient bioavailability. 7. Support for gut microbiota. Camel milk helps promote beneficial gut bacteria. 8. Synergy with camel milk's natural antimicrobials. Compounds like lactoferrin and lysozyme enhance microbial protection. Role of beneficial bacteria in preserving camel milk. Beneficial bacteria help preserve camel milk by fermenting lactose into lactic acid, which lowers pH and slows spoilage. They produce antimicrobial substances that reduce pathogens such as E. coli and Salmonella. They also extend shelf life, especially in hot climates, and enhance the flavor and texture of fermented camel milk products. Additionally, they improve digestibility and nutritional value. Health benefits of beneficial bacteria. The probiotics in camel milk provide multiple health benefits. They support gut health, improve digestion by breaking down lactose and proteins, and strengthen immunity through antimicrobial and immunomodulatory effects. They may also reduce inflammation and oxidative stress and help maintain a healthy gut microbiome. Impact of milking and storage methods on beneficial bacteria. The presence and stability of beneficial bacteria in camel milk are highly influenced by how the milk is collected, handled, and stored. Camel milk naturally contains probiotic bacteria such as Lactobacillus, Bifidobacterium, and Streptococcus, but their survival can increase or decrease depending on environmental conditions. Milking hygiene. Clean milking practices help preserve beneficial bacteria while reducing harmful pathogen. Contamination with dirt, fecal matter, or unclean utensils can introduce competing or pathogenic microbes. Using sterilized containers and washed teats helps ensure the natural microbiota remains intact. Temperature effects. Camamix ciotar amolate discret temencraresu punsens kautu ofticui acto osetcnls, 8 ud osetchs. Refrigeration, 4 degrees Celsius. Slows the activity of all bacteria, both beneficial and harmful, prolonging shelf life, but reducing probiotic growth. Freezing preserves bacteria but stops their metabolic activity. Heat treatment. Pasteurization kills most beneficial bacteria along with pathogens. Raw camel milk generally contains a higher probiotic load compared to processed milk. Storage time. Fresh milk contains the highest amount of beneficial bacteria. Over long storage periods, even under refrigeration, probiotes begin to decline. Oxygen exposure. Some probiotic bacteria are microacrophilic, prefer low oxygen, wide mouth containers, or shaking the milk increases oxygen exposure and reduces their survival. Industrial and medical applications of camel milk microbiota. Camel milk-derived beneficial bacteria show promising applications in food,
pharmaceutical, and medical fields. Their unique resilience to harsh environments makes them particularly valuable. Natural preservatives. Bacteriosan. Some camel milk bacteria produce bacteriosan, natural antimicrobial peptides that inhibit foodborne pathogens. Can be used as natural preservatives in the food industry. Reduce the need for chemical additives. Medical and therapeutic potential. Camel milk probiotics may contribute to enhancing immune response, reducing inflammation, supporting treatment of gastrointestinal disorders, anti-diabetic and anti-inflammatory activity, as shown in recent studies. Biotechnological applications. Camel milk bacteria show high stress tolerance, right pointing arrow, useful in enzyme and metabolite production. Applications in bioactive compound synthesis. Potential for future pharmaceutical development. Probiotic production. Beneficial strains from camel milk can be isolated and formulated into probiotic capsules. Functional food additives. Fermented dairy beverages. These probiotic strains often have better tolerance to acidity and heat compared to those from cow milk. Fermented camel milk products. Industries can use camel milk bacteria to produce camel yogurt. Fermented drinks, similar to kefir, therapeutic fermented milk for digestive uses. These products may support gut health due to their high bacterial viability. Between beneficial bacteria in camel and cow milk. Camel milk. Higher microbial diversity. Dominant lab. L. fermentum, L. plantarum, L. helveticus. Contains bifidobacterium and desert-adapted beneficial strains. Strong antimicrobial activity. Highly heat and acid-resistant bacteria. Slower fermentation but produces unique antimicrobial peptides. Stronger anti-inflammatory and anti-diabetic effects. More diverse probiotic profile. Cow milk. Moderate microbial diversity. Dominant lab. Lactobacillus acidophilus, L. delbrueckii. High amounts of Lactococcus and Streptococcus thermophilus. Moderate antimicrobial activity. Less heat and acid-resistant bacteria. Excellent for commercial fermentation. Yogurt. Cheese. Well-studied probiotic strains. Offers gut health benefits but less potent. Conclusion. Camel milk is a unique and naturally rich dairy product because of its diverse microbiome and high content of beneficial bacteria. These bacteria, especially lactic acid bacteria, contribute to the milk's strong antimicrobial, anti-inflammatory, and probiotic effects. Their activity and quality are influenced by how the milk is collected and stored, making proper milking and storage methods important for protecting these beneficial microbes. When compared to cow milk, camel milk consistently shows greater microbial diversity, stronger and more resilient probiotic strains, and more pronounced biological benefits. Overall, camel milk stands out as a valuable functional food, largely due to the unique and powerful community of beneficial bacteria it contains.